What is recursion? Let's look at why it's important, how it works, and how we can use recursion and Python to solve the Towers of Hanoi problem. Recursion is really important to understand because it can be a neat and elegant little trick to solve complex problems, and it is used in lots of different places in computer science and data science. So divide and conquer algorithms, they are usually recursive. So something like binary search, that is a recursive way of searching through a list of numbers. And in data science, decision trees, they are recursive too. So it's as well that you understand them, but they're also quite interesting and fun in the way that they work. A recursive function is a function that calls itself. So when you call the function for the first time and that function executes, as part of the execution of that function, it calls the function again. From inside the function, it calls itself. Let's have a look at an example. The mathematical function factorial, the one that's written with an exclamation mark, that gives a nice introduction into how recursion works because it's quite a simple function. So you remember factorial, okay? It's to calculate it, you take the number whose factorial you want to calculate and you multiply it by all the lower numbers. So 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And so one way of doing that, if we wanted to write a Python function that was going to calculate factorial, we could do that by using a loop. But a much better way, or a more interesting way, not always better because recursion can use more memory, but a very interesting way of writing that is to use recursion. And the way to think about that is if we want to calculate 5 factorial, which is 5 times 4 times 3 times 2 times 1, well, that's just 5 times 4 factorial. So if we were writing a function, we could say, take the number that you want to calculate, whose factorial you want to calculate, and multiply it by the factorial of the number below it. So you could say that 5 factorial is just 5 times 4 factorial. But then you have to calculate 4 factorial. So there's a function called a 4 factorial, but what's 4 factorial? Well, 4 factorial in this function that we're creating is just 4 times 3 factorial. And 3 factorial is just 3 times 2 factorial, and 2 factorial is just 2 times 1 factorial. But when do you stop? You don't want this function to keep going down by 1, to be trying to calculate factorials of negative numbers. That's not going to work. So this has to stop, and it has to stop at the simplest version of whatever it is you're trying to calculate. And that's known as the base case. So whenever you're writing a recursive function, whenever you're using recursion, you have to know where the recursion ends. What is that base case? At what point do you stop and return a value? And in the case of factorial, this function that we're calculating here, that's going to be at, well, I never know actually, because 0 factorial is 1, so it could be at 0, I guess. But for the sake of this, let's call it 1. So 1 factorial is 1. Right, so you've probably noticed that the colors changed a bit on the screen, and that's because I just noticed that the white balance hadn't been set up properly. I did it before I started recording, but then the battery ran out, and when I changed the battery, the white balance reset. So anyway, it looks a bit better now. What I want to do now is use Python. I want to write a Python function to use recursion to calculate factorial. And you'll see just how simple it is. So this is how we'll do it. Let's start by writing the name of the function. We'll call it factorial, and it's going to take an integer. We'll call that integer n. Now, if n equals 1, that's our base case, right? So if n equals 1, we just return n. So if n equals 1, we return 1. In every other case, we return n multiplied by the factorial, so this function that we're writing, of n minus 1. Now, you could also put a check in there to make sure that you're not getting a negative number, you could do that. But I didn't want to do that here. I just wanted to show you how easy it was to calculate factorial using recursion in Python. So in a room, in a temple in Hanoi in Vietnam, legend has it that there are 3 posts. And on one of these posts are 64 discs. And it's the job of the priests at the temple to move these discs according to a certain set of rules from one post to another post. And once they complete that task, the legend says the world will end. So what I want to know is, how long is this going to take? Are we in imminent danger of the world ending because this task is almost being completed? Now, the truth is a little less mystical than that. Actually, this is a puzzle that was created by a French mathematician in 1883. His name was Edward Lucas, and he was famous for his work on prime numbers. And this problem is related to prime numbers in a way that we will look at a little later on. But this is a problem that can be solved using recursion. And so what I want to do is I want to go over the rules of the problem with you, and then I want to see how we can solve this problem using recursion, and we'll write a function in Python and then count how many moves it would take to transfer those 64 disks from one post to another post, and see how long, if the legend is correct, we have until the world comes to an end. Let's do that now. So I have a little Tower of Hanoi set here. We've got the 3 posts, and on one of the posts we have 5 disks. And the rules are quite simple. You can only remove the top disk from a stack of disks. So the only disk you can remove from any stack is the top disk. And you can't put a large disk over a small disk. So this would be an illegal move. You can't do that. You always have to put a small disk over a large disk. And that's it. Those are the only rules there are. So thinking about this recursively now, what's the base case? Well, the base case is when we have just one disk to move. So if I take these 5 disks away and put them there for now, and I just put one disk on that post, the base case is just moving that disk from one post to another post. So now that we know the base case, how do we use recursion to move just 2 disks? And what we want to do this time is move these disks from the source post to the target post. How are we going to do that? Well, we know the rules and we know the base case. The base case is that we can just move one disk pretty much wherever we want it. So why don't we do that here? We could move this top disk out of the way so that we can move this bottom disk underneath where we want it. Let's try that. So we'll move this disk out of the way. We know we can do that. That's the base case. It doesn't break any rules. And now we can move this disk to the target post. And now we just move the disk that's on the middle post to the target post. And we have moved 2 disks from the post that we started from to the target post, and that was quite easy. And that really provides the key to move any number of disks. So let's look at the case where n equals 3. Now, can we think about how we solve the 2-disk problem and apply that to 3 disks? Well, with 2 disks, we just move the top disk out of the way and then move the second disk to the target. Now, if we were to do that with this, we'd have to move these 2 disks, because the bottom disk now has 2 disks on top of it. We'd have to move these 2 disks out of the way to the middle post, and then we move the bottom disk to the target, and then we can move these 2 disks on the middle post back on top. But that breaks the rules, because we can only move 1 disk at a time. But if we go back to this again and look at how we're trying to solve this, we want to move these 2 disks out of the way so that we can move this disk to the target. So we need to move these 2 disks here. But we already know how to do that because we've moved 2 disks before from the source to the target. Now we want to move these 2 disks out of the way so that we can move this bottom disk to the target. But we know how to move 2 disks because we've already done it. So if we want to move these 2 disks to this is the target now for these 2 disks. Well, we just move the top disk to the spare. This is the new spare now because in this case, this is the target. We move the second disk to the target, and then we move the top disk back. And we've done what we wanted. We've moved those 2 disks now here so that we can just move this disk across, and then we need to move these 2 across to here. But doing so 2 at a time breaks the rules. But we know how to do this now. This is a problem that we've already solved. So we need to move this one here so that we can move this one here, and so that we can move this one here. And we've achieved our aim of moving the 3 disks from the source to the target. And now n equals 4. Applying the logic that we applied before and knowing the rules, what we'd like to do is move these 3 top disks out of the way to put them in the middle so that we can move this bottom disk across where it needs to go, and then move these 3 disks on top of that bottom disk on the target post, and we've done the job. So that's going to be the approach, but of course that breaks the rules because we're not allowed to move 3 disks at a time. We want to move these 3 disks here, but we can't do it all at once. But we've already solved the case where you move 3 disks, and we solved that by looking at the case where you move 2 disks. And we could solve that because we knew how to move 1 disk. So this is the recursion coming into play. We want to move these 3 disks now to this one. Before, when we just had 3 on this post here, we wanted to move the 3 disks here. But now we want to move these 3 disks out of the way onto this spare post so that we can move this bottom disk to the target post and then move the 3 disks on top of the bottom disk. So now we need to move these 3 disks here, and we know how to do that. We've already solved that problem. In order to move these 3 disks here, we need to move 2 disks. We know how to move 2 disks, but we need to move these 2 disks here. And in order to do that, we have to put 1 disk here, and then we put this disk here, and then we move this disk here. And now we've moved the 2 disks where we want them, and then we can move our 3rd disk here. And now we just need to move these 2 disks back on top of this. Well, again, this is a problem that we've already solved recursively. So we have to move the first disk out of the way, and then the second disk goes here, and then this disk comes back here. And now we've cleared a space for this final disk here, this 4th disk. We can move that across just as we wanted to, and now we can move these 3 on top of this. But of course we can't move 3 at a time, so we have to use recursion. So now we want to move these 2 disks out of the way so that we can move this one across, the bottom disk to here. We have to move these out of the way, but that breaks the rules, so we have to go back to the base case, and the base case is that we just move 1. And we move it there. And then we move this one here. And then we take this one and we move it here. And now we've moved the 2 disks out of the way. We can put disk 3 there. And then we just need to move these 2 back here. Now we've done this. We've solved this already. So you can see now how we're building up a recursive solution. And we can go on and on solving it in that way, just by taking, let's look at the case where n equals 5. We want to move the bottom disk here, so that means we have to move these 4 disks across to here, and then we can move this one across to here. Now, of course, that breaks the rules, so what we need to do is we need to find a way of moving these 4 disks, we need to be able to move these 4 disks to here, but we've already solved that problem. We know how to do that, and we do that by moving these 3 disks to here, but we can't do that because that breaks the rules, so we need to move these 2 disks here, but that breaks the rules. And the answer is that we start by moving this disk here. Now, I'm not going to work through this solution, but you get the idea. We now need to find a general way of expressing our thoughts. So where we've been looking at examples, we've been looking at concrete examples where n equals 2 or 3 or 4, but we need to express this generally now. So how do we do that for n? Well, we have 3 posts. Let's call them A, B, and C. And we want to move n disks from A to C. Now, the way we're doing that is we're moving n-1 disks from A to B. So we're moving all but the last disk from A to B. We're then moving that last disk n from A to C, and then we're moving those n-1 disks from B to C. And that's how we can generalize what we've been doing in those specific examples. So now that we've generalized our solution, we can write some Python code, we can write a function that will be able to do this for us, and it'll be able to count how many moves it takes to transfer the disks from one post to another. Let's have a think about how we're going to write this function. We have this little visualization here. We've got our three posts, source, spare, and target. Now these are the generic names of these posts that are going to go into this function. So this function has placeholders for the parameters that eventually will go into the function. And these placeholder names, these placeholder variables are source, target, and spare. Now the actual variables that will be going in here are these lists A, B, and C. And in this case, A is a stack, or a list, with 5 disks, and B and C are empty. And what we're going to be doing is moving these n disks from the source to the target. Now how do we do that? We take n-1 disks, that's the ones apart from the bottom one, and we move these to the spare so that we can then move the nth disk to the target, and then we have these n-1 disks here, and we're going to move those across to the target. So we've already started writing this function. So let me just add to it now. So if n is greater than 0, we want to take this time the n-1 disks that are here, and we want to move them from the source, but this time we don't want to move them to the target. We want to move them to the spare, using the target as the spare this time. That will move them out of the way. When we've done that, what we want to do next is we want to move this bottom disk from here to the target. So the first thing we have to do is we have to get hold of that disk. And we can do that by using pop. In Python, pop will return the top of a stack, or the last item of a list. And so we have source dot pop. So that works, but we need to put that on the target. And the way we can do that, target is a list, so we can append that, target dot append the whatever's popped here from the source will then be appended to the target. Now, I haven't kept this aligned properly. This needs to be aligned in here like this. But you get the idea. So we've now moved this across. So we've moved the n-1 disks from the source to the spare. We've now moved the bottom disk from the source to the target. And now we just need to move the n-1 disks that are here. We need to move them from the spare to the target using the source as the auxiliary. And that's it. Now, Wikipedia has a really good explanation of the Towers of Hanoi, and I adapted the code that we've just seen from the code on the Wikipedia page. So let's run this code now, because we've still got to answer that question, haven't we? How long would it take those priests to move the 64 disks from one post to another post? So here's the code that I've written, and what I've done is I've created a loop as well so that it will run with varying stack length, starting from 1 and going up to, well, it only goes up to 25, because as you will see if you run this code yourself, it'll cause problems for your computer because the numbers just get too big too quickly. The number of moves required as we increase the number of disks goes from 1, then to 3, then to 7, then to 15, then 31, then 63, then 127. And that pattern should seem a little familiar because it's just 1 less than powers of 2. So powers of 2 are 2, 4, 8, 16, 32, 64, 128. And what we have here is 2 to the n minus 1. Now, these are interesting numbers. They are called Mersenne numbers after another mathematician. And some of these are prime numbers, and it's a way of generating prime numbers. And you can read up about that on Wikipedia. But if you were to use 64 disks, it would take approximately 600 billion years if those monks, if those priests were moving one disk per second. So it'd take quite a long time. Anyway, I hope that's helped you understand the towers of Hanoi. When I first started studying computer science and programming, I found the towers of Hanoi quite a difficult problem to understand well. And I hope now, if you practice, go away and write that code yourself, and don't look at it, so understand it and then go away and try to write it yourself and see if you can do it from scratch. Think about what the base case is. What's the base case in that code that we've written? Which line is the base case and why and what's going on? And try to think of the recursive calls as well as we go through the stack, and that function is called recursively, and from inside the function, those n-1 function calls. What's going on there? And why haven't we explicitly put if n equals 1, then do this? How does the code that we have, where we have if n is greater than 0, how does that account for the base case? Think about those questions, and then go away once you've thought about them and try to recreate that code for yourself without looking at it, and see if you can change it, see if you can do it in a different way. And also think about the data structure of the stack. Now, the way this problem is set up, the way the Towers of Hanoi is set up, it actually is a very good way for you to start understanding how stacks work. I'm not going to talk about stacks in any detail here, but it's a data structure that you should really know about, and understanding this will really help you to understand what a stack is and how it works. If you've enjoyed this, then go and check out my Python course on Udemy. It's a 10-hour course aimed at beginners. We cover this problem and other problems too, and I think you'll like it.